we manufacture our products. It's a German engineered system that we build in Langley, BC. And so, of course, everything's built to meet NFRC certifications, NAFS compliance standards, and all that good stuff. We have products that are Passive House certified, and they've been in lots of different types of projects. You can see a little bit of a smattering here from really funky alpine huts to high-rise towers and everything in between. Sorry. I'm not sure what to do with this little Zoom window of people. Sorry about that. So we have a long history of manufacturing windows and doors for high performance projects. And 10 years ago, Innotech built the windows for its first Passive House Certified project, the Bagley Nature Center in Duluth. So this classroom was designed by Carly Colson, a true pioneer in sustainable design. I'm a total fanboy. This project achieved 0.47 ACH 50 and has won tons of awards for its many sustainable features and overall performance. In the last few years, we've seen a tremendous growth in Passive House projects, particularly here in BC because of the BC Energy Step Code and City of Vancouver building bylaws shooting for the greenest city. Innotech is currently involved in over a dozen projects that are targeting Passive House certification, including 11 multifamily projects. Some of them are nearing completion, while others just received their building permits. These 11 projects don't include any of the multifamily projects that are targeting step 4 or step 5 of the BC Energy Step Code, or any of the deep energy retrofit projects that we're working on. So everyone involved in these multifamily projects and any other high performance or Passive House project is leading the industry. And when you're leading, you're often creating your own path. Everything is relatively new when it comes to designing and building multifamily Passive House projects. While the standard has been around for decades, it's still new in practice for most, even for people at the forefront of the movement. So there's a lot of learning involved for everyone, and that includes us. For example, we've been continually refining and developing new improvements on the system since we started the journey. There's a few different projects pictured here, and a couple of them we'll highlight in later slides. Projects are in that we're working on right now are in BC, Oregon, Alberta, and Ontario. Talking about using windows really only makes sense in the context of a building. So the evaluation of a window should remain contextualized against the rest of the building. In what way is the window a good choice in context? There's a lot to it. I think a great starting point is to look at a great window. I happen to think that's a picture of one right there. It's designed with intent and executed skillfully. But that's just a starting point. The best window installed badly will perform poorly. I've heard some Marines refer to the 7 Ps. Proper prior planning prevents piss poor performance. And I'm not going to disagree with the Marine Corps. So the question is, what goes into that proper prior planning? The short answer is lots. The first tip to get the most from your windows and doors is not to design with a generic brand. This may seem obvious, but a large number of the projects we come across do make this mistake or misstep. 2 things will happen if you design your project with a generic brand. First, you'll most likely have to redesign the openings once you've selected a window and door manufacturer. This can take time, can cost money, and can be a band-aid fix. And second, a generic brand or redesign devalues your investment in high-performance fenestration because it doesn't take into account the limitations or the advantages of a specific brand. Sam McAfee of Zola Windows said something that we agree with and also say, not every window and door manufacturer is right for every project. When you design with a generic brand, you're essentially assuming that every window is the right fit for your project. And you're not taking advantage of the strengths of anyone. So you'll get the most performance out of your windows and doors and from the overall project when the windows and doors are carefully considered from the onset of the project. This project here, I really like. The Maitland Street Village is a recently completed affordable housing project on Vancouver Island here in BC. It was designed to achieve step 4 of the BC Energy Step Code. This building to me is an excellent example that challenges the notion that affordable housing or social housing is inherently of poor quality. It's a well-designed building executed with great skill and attention to detail, and the result is a home that will keep many people safe, secure, and comfortable with minimal energy use for many decades to come. The building was designed and built to achieve step 4 of the Energy Step Code. For those of you that are unfamiliar with that local code, step 4 for MERBs changes based on climate, but in this region, under 3,000 heating degree days, it is similar to PHI. Max TEDI 15 kilowatt hours, max QE 100 kilowatt hours, air tightness of 1.0. This building was 0.37 ACH 775, so it's pretty reasonable air tightness, I would say. Some of the high performance details include R50 roof, 4-inch R20 exterior insulation, triple glazed windows, electric baseboard, heating in the bedrooms, and mini split heat pumps for heating and cooling. It's also net zero ready. The infrastructure for solar power conversion is in place for parking stall solar panels, and that'll provide enough energy to power the entire building. So talk about affordable. The exterior insulated assembly shown here is safe from condensation risk in an extremely wet environment. This building's exposed to the raw Pacific Ocean weather. You may also notice the window sitting just a little proud of the structural wall. In my opinion, we must above all always remember that there is an occupant. The user experience within a space should be the critical factor that informs every decision. I know form versus function can be a hotly debated subject from an artistic perspective, but I think we have a collective goal for housing and the environment, and it requires buildings to be more efficient, more effective, more affordable, more durable, more comfortable, and safer for occupants. To accomplish that, there has to be a necessary elevation of function and utility. So not to sacrifice form, of course, but to balance and allow form to flow as a result of those user functions. The pictured here is the Juicy Salif, and it's the greatest terrible design that I love and hate. Is the room comfortable? What does it mean to be comfortable? In most cases, we'll look at even temperature as a huge focus of comfort, but air temperature is only one factor in thermal comfort, and it's less impactful than radiant temperature. Radiant heat will influence how we gain or lose heat to the environment to a very significant degree. I have some other slides that look at heat later. But also, is a window comfortable to operate? Handles that are too low or too high can be problematic, while an average person may have some difficulty in reaching a tall handle. It's just downright impossible for somebody with impaired mobility. Similarly to somebody in a wheelchair, for example, trying to operate an awning sash down at the floor, or for some very large windows or very heavy windows, you can have additional tension on the hardware that when you want to operate, that can make it very difficult. The ventilation of windows can be a huge and complex topic, but there's a couple of constants to rely on: the stack effect and convection. Warm air rises, the molecules excite, they move and space out, they decrease density and cause the warm air to float above the heavier, cooler air. At the same time, that causes the pressure to increase. So if you have an opening higher up in a space, that higher pressure of the warm air will push its way out the opening. The stack effect then draws air in the lowest available opening, which is likely to be cooler air. So in a tilt-turn window, the opening reduces towards the bottom. That also takes advantage of the Venturi effect. So as the opening decreases in size, the velocity of the fluid, the air, increases, and it promotes a natural convection current, moving the air throughout the room. which will most likely help reduce the temperature of the air, but moving air will also cause greater heat loss in static objects, even when the air temperature doesn't change. So overall, you have much more effective passive cooling and an increase of the ventilation rate since you're focusing on the higher pressure air. So the greatest possible volume of air will move through the window opening. On a related topic, the stack effect on facades can be important. So as your facade heats up from the direct sunlight, the warm air rises along the face of the building. And depending on operation, an awning window, for example, will direct warm air into the building, increasing the heat buildup and trapping increasingly warm air inside. Of course, in a tilt-turn window, the air that's being drawn in at the bottom may still be a warmer air, so the cooling benefit can be somewhat diminished. You aren't causing a buildup of heat, but you may not be doing a lot to cool the air temperature. Then you're relying on the convection currents to reduce surface temperatures in the space. But if you were to place that ventilating window on a cold facade, so west in the early morning, north all day, east in the late afternoon, you're able to draw in cooler air because it's not being heated by the facade. And you can make the best use of passive cooling methods that way. Sight lines and handle position. A positive user experience is important. You can design and build the most energy efficient home or building, but if it isn't enjoyable to live or work in, then it's missed the mark. Some simple questions. There may be things like floor to ceiling windows in some cases may look great, but are they necessary? Obviously, for light and view, they can add some great positive benefits, but sometimes they're put in places where there is no view or light to be gained. This photo here shows a coupler that is located right in the sight line of somebody that's sitting. The handle looks a little bit out of reach, especially for someone that's a bit shorter. So realistically, a better design probably would have been to put the operable on the bottom with the fixed section on top, or better yet, reduce the overall height of the whole window unit to design it so it can just be 2 window sections rather than 3 portions of window. This would have decreased the overall cost of the window, improved the overall performance, improved the sight lines, and made it easier to operate. So another thing to mention is grids are back in style. We see them a lot, and if performance is top of mind and you care about the budget, we would recommend not jumping on this trend. They add expense. They're a real pain in the butt to clean, to be honest, and I would be interested to see if that's something that people want to calculate out and include in the PHPP, the reduction of glass area that affects your COG values, and potentially when you put an object like that on the glass, you can cause a change to the thermal value of the unit as well. So it is worth taking a look at if you're concerned about the details. One of the main considerations when designing and placing windows in the building for high performance is to minimize frame and maximize glass. A couple of weeks ago on the Passive House Accelerator Construction Tech Series, Doug Pruis spoke about manufacturer size limitations and window sizes. And he used the term Frankenstein window to describe a window that's a little bit of every brand, and this is exactly what we want to avoid. Just like Doug said, make sure you know what the size limitations are for your manufacturer of choice and then work within them. There's an optimal size for a window. The optimal size will vary for each manufacturer. As a general rule, bigger is better. Now, I didn't say that the biggest possible window is better, just that bigger is better. So much as you already deal with window to wall ratio, think of windows in terms of glass to frame ratio, but almost in the inverse. Too much frame compared to the amount of glass will lower the overall performance of the window, even for Passive House Institute certified windows. in North America, homes and buildings tend to have much more fixed windows than operable ones. And the operable windows can often be very small. This is because operable windows have historically performed more poorly and had hardware considerations that restricted them more than fixed windows do, obviously. But while the technology has improved, a lot of people are still designing to accommodate for those lower performing operable windows. And it no longer makes sense to do that, to design with few and small operable windows. Effective natural ventilation is an important factor for passive house projects. And at Innotech, we manufacture dual action or tilt turn windows, obviously. And from a functional perspective, for everyday ventilation, the windows are simply tilted. The swing function is actually not used a whole ton. It's really intended for egress and maintenance and cleaning purposes more than anything else. To maximize ventilation on a tilt turn window, it's not just about that height of the operation, but when you take a look, the largest opening is right up at the top. You get this nice continuous rectangular opening. So the larger opening is at the top, and the size is dictated by the width. So a wider opening will provide greater ventilation. Last year, during our first component spotlight, I spent a lot of time discussing quantity, size, and position. And I'm not going to go into detail on that today, but I do want to quickly mention some of the key points. Limit the number of wall penetrations by combining openings into single larger openings. Not only will this reduce your risk of air loss and thermal bridging, but it's also less expensive. The price per square foot of small windows is higher than larger windows. You'll be saving on framing, installation, air sealing, interior and exterior finishing. This net zero home pictured actually has, believe it or not, these are drastically simplified openings compared to the original concept. It was designed at first at base coat, so a far cry from net zero energy. And all of the divisions, the mullions that you see in those windows, were actually framed opening separations. So instead of the 7 window units you see on the elevation, they would have had 15 separate window openings. So this facade is a huge improvement, and kudos to the designer and builder for being willing and able to make the change, particularly within the original design concept. Now, this home, on the other hand, shows a pretty simplified approach to the windows. I would say, in my opinion, contemporary designs may have an advantage when trying to simplify and remain consistent in terms of design, but that's obviously not an absolute. So one of the things that I covered in the previous one is a common design that we see. So this is about a 7 foot by 8 foot window. It's got operable sashes down at the bottom. It's poor functioning ventilation. It's difficult to operate. You have to bend down, crank open the window. The operable sash is small. The horizontal mullion will interfere with seated sight lines. But if we try to push something to option 2, it will be less expensive, a little more functional, but moving the fixed portions up to the top is much more optimized for use. You still keep the main ventilation point above head height, but it drops the handle height by 2 feet and brings it into ADA compliance. So it's very effective all around. And option 4 is actually a tilt turn door, which simplifies pretty much everything there and is pretty self-explanatory in terms of simplification. The River West apartments in Vancouver, Washington, these windows are a pretty good example of that optimized for use design concept from the last slide. So they have a nice sized operator, convenient hardware placement. The ventilation on these would be pretty good, I think. They have large fixed panes for the view and the light. It could be simplified further, but I mean, obviously, it looks great, functional, and they had project goals that that meant that these windows were the right fit. When we're looking at some of the things that can be complications in windows, this is a window design that we saw from a project, and this is definitely something that you would consider a more traditional window design on a multifamily project. The operators are limited in size based on hardware, on function. And what's interesting is as we take a look at this, you can look at the different air seal potentials on windows like this. When you want to really think about what's the positive and negative, so it's completely aside from any of the factors of form. This is just purely function and how well this window will help you meet or miss your air tightness goals. So this frame to sash, this window has a joint from the frame to the glass, from the sash to the glass, and from the frame to the sash, totaling about 51 feet of potential places for air ingress. This window over here, window 1, has this frame to sash seal, this sash to glass seal, and these frame to glass seals here that totals about 71 feet. So in the same sized window opening with less glass area, so less light, and significantly undersized ventilation compared to the optimized design, it's actually 41% more linear joints to allow for the potential for air ingress. Similarly with thermals, you're going to have a bunch of different spots. Wherever you put in any kind of structural element like a mullion or a coupling, you're going to increase the rate of thermal transfer. So from the base frame that exists in this window, you're adding in frame profile, you're adding in these horizontal mullion profiles, you're adding in these vertical mullion profiles. In this window, you have an addition of frame profile and one vertical mullion. The red line is the ventilation point. It's actually about the same width of ventilation in both examples. But the amount of air that's going to transfer through those spaces is drastically increased because of the height difference between those two operators. Why tilt-turn doors? Sometimes the design of the space really does call for it. Instead of a door for egress with an operable side light next to it for ventilation purposes, we can just simplify and combine both concepts together. Use that door for secure, effective ventilation. And not gonna lie, I'm pretty envious of that view. Now, you don't have to live in fair Verona to appreciate a Juliet balcony. They are meant to bring the outdoors in, which itself has a bit of a romance, I think. They have several benefits and become especially fine if there is a solution that eliminates the typical complications that they can bring with your envelope. For us, an integrated thermal-free Juliet balcony solution is available. The connection does penetrate through the exterior portion of the frame, but it doesn't. It ends in the rain screen cavity, so there's actually no change to the thermal balance of the thermal value of the unit. One of the big considerations that I think is worth looking at and keeping in mind is the potential to design for offsite construction. Some of our construction methods may be changing now compared to the traditional, and using the windows effectively from a bunch of different perspectives may be different than what you're used to, and installing on site is a lot less efficient than installing in a factory setting. But There may be size limitations to what the factory can handle, to what is reasonable for shipping. And you also have to consider how the panels are going to be shipped and handled. Shipping flat is not ideal for glazing. So are there ways to get around that? You can simplify the window and door designs. You can have more operable windows because the sashes can be easily installed on site. So that protects glazing during shipping and assembly. And one of the beautiful things about offsite construction, these wall assemblies, much as this one was in this project, you can test the installation for best performance. So they knew 100% long before sending these out to site that these windows were functioning as designed and intended. It was absurdly quick how fast this envelope went together, because it's basically drop that wall panel in place and wrench up the structural connection and put a bead of caulking around the exterior edge, and you are totally ready to face the elements. Orient carefully. Much as you orient the building to take best advantage of the property, the surroundings, the sun, etc., you should also consider where to place windows and what that affects for the occupants. That south-facing window will work wonders for the solar heat gain in the building model in the winter, but what if it's floor-to-ceiling glass in the breakfast nook? Is the specific heat that's landing on that one spot in the room that's most likely to be occupied by a person for an extended period, is that going to be ideal for that person's comfort?
Oh, good. No. I had to figure out how to.
And if it's not, how could you make use of shading, for example, to prevent the potential negative aspect? So every time you create an opening in the envelope, there should probably be a specific reason for it, or better yet, several reasons. Bedrooms, living rooms, kitchens, bathrooms, offices, they all have different occupant needs. And it may be worth challenging some traditional notions in a high performance home. Be intentional about each opening. You can ask simple questions like, is it helpful to the view to have glass at the floor level? Or do I want to open a window directly above my sink? Or can I move the operator somewhere else in the kitchen? Reduce the complications wherever possible, and increase the size of the units to match the room layouts, the goals for lighting, the solar gain, ventilation, movement of people and objects, etc. So intention is really key to the whole thing. It's not about don't do this or don't do that. It's about ensuring you know why you want to do this or that, and then ensuring that what you want to do will actually function as intended without negative consequences, or maybe you need to ensure that it functions without consequences that you have failed to anticipate and account for. Challenging or questioning the standards is definitely worthwhile. This kitchen to me is a great example of that. There are several departures from the traditional here, and I absolutely love this kitchen, the layout, the design, everything about it. This works perfect for me. I would work in here in a second. I also want to talk about solar heat gain. It's a dynamic topic with a lot of variables. It doesn't specifically relate to this kitchen, but it relates to, every room in a home. So I'll talk about it now. I don't want to get stuck in the weeds, but I do want to give you a couple of important things to keep in mind. As you increase heat gain, it will decrease the thermal performance of a unit. It's a necessary balance that occurs. If you're going to allow thermal transfer in one direction, you are going to have another thermal transfer in the opposite direction. Everything's has some kind of a balance. So it needs to be carefully considered and balanced within the context of the building. The energy trade-off and the effects on the occupants will be different on each facade, and maybe even on each individual room or window. And it's probably not appropriate to use the same coating or glazing on an entire building. One of the strengths of local high quality manufacturers should be the ability to easily accommodate these types of needs, to vary the glazing types as you require it to meet your building model. Now, active or passive shading is a strategy. The perfect orientation of the building to meet all of your passive house goals and to have, you know, nice overhangs and elements may not be possible or sensible based on surroundings, other buildings, law constraints, building code limitations, natural vegetation, the views, the use of the property, or simple aesthetic preferences. Understand the constraints at the onset of design so that you can plan effectively. Now, there's a bunch of different materials and fabrics and types available for shading of all kinds. Passive shading is the use of, depending on the strategy. This one in particular, the project is UBC Evolve in Vancouver, ZGF Architects or ZGF Architects up here in Canada. Uses a combination of vegetation and aluminum shroud to provide passive shading to the project. It's actually a pretty interesting shroud, and there's lots of trees along the west face. It's quite interesting. We do actually have, this project is just completing right now, basically. And we do have some great photos, but the timing didn't work out for permissions and stuff. So unfortunately, I can't show them to you here. But you can see these, it actually does look very much as designed. It's, I know that doesn't always occur, but it certainly did occur in this case. And these shrouds on here are actually quite neat and pretty effective. We've taken some photos at a couple of afternoon times, and you can see very good coverage of the windows from the sun. This is a different project. To me, it actually, oddly enough, there's something about the lighting dynamic that it looks to me like a 3D rendering, but this is actually a project photo. So those shading panels, so whether it has to do with the surroundings, I don't know if there's some other tall buildings across the street, but they didn't require very heavy shading. They just needed a little bit of assistance to keep some of the heat off the sun for a period of the day. So they've got this, you know, semi-opaque panel that looks pretty cool on there. Active shading. So this is actually my house here. This window has no chance for shading in the afternoon light. The view is amazing, but most of the time, it's best to prevent the intrusion of excess solar heat. This particular shading solution is wireless, solar powered, and simple to install as well as use. I just drop it around 3 p.m. and raise it back up at bedtime in the high heat period. So from around now until mid to late August is about when I would actually make use of this. As this is a bedroom, it's unoccupied for the majority of the day. So a solution like this that impacts the view is totally acceptable no matter what. The goal is to prevent additional heat that would add to the specific heat of this particular room that would be a problem when we go into occupy it at bedtime. So the building energy model accounts for the heat gain in general. So an internal shading solution actually works fine for the other west-facing windows in the home where it's impossible to have an adequate overhang. So that particular shading solution, this is one of their shop drawings I borrowed. It's a pretty cool solution. You can see on here, the way that it mounts is actually from the interior. You open the window and push it up against the frame. So there's no damage to the window frame. There's no wiring to deal with. There's a solar panel on the face of the the roller cartridge, and that's about it. So it takes about a minute to put in, and you can start clicking buttons and controlling your heat gain. They have actually been used on a couple of multifamily projects around here, and they've got them hooked up to an array of, they've got solar sensors and they've got thermostat controls in, so everything balances out. There's manual overrides for the occupants inside. So there's a whole bunch of really fancy things that you can do. But of course, that's getting to be a pretty far cry from a passive concept. So, you know, you use these when you need to, but I would be surprised if anybody would want to use this as their automatic go-to. Mindful connections. Obviously, your window has to go into a wall, which means you need to make some connections to your structure, to the various surrounding materials. Be mindful of those connections, what they are, why they're required, how they're achieved, also how they can be stressed or affected throughout the life of the building so that you can anticipate and prevent potential failure. Buildings move, materials expand and contract, the ground shifts, buildings settle over time, the occupants and use can cause movement or deflection. The elements can act on everything as well. Wind can create an amazing amount of pressure that not only pushes on the parts like the windows, but it can actually shift the entire building and cause pretty significant movement. So windows exist within the building structure. So all of the stresses that act on the structure can transfer to the window. So if the attachment of the window to the wall is properly designed and executed, those stresses should be minimized to improve the performance and durability of the window. We, like a lot of high performance window manufacturers, use a form of strap anchor. So it's a semi-flexible attachment method that highly resists wind loading, but allows for movement in other directions, whether that's shear movement, settling, deflection, heaving, etc. There are some additional benefits, such as the flexibility of placement in the wall or the ability to install entirely from the interior. But the main driving purpose of that strap anchor concept and design is to account for building movement and reduce the transfer of stress. Okay. So as much as your wall assembly needs to accomplish all 5 critical barriers, your window needs to correctly tie into and also accomplish all 5 barriers. A properly designed window and door system should incorporate the same principles as a properly designed wall assembly, meaning they should have pressure equalized rain screen, continuous airtight layer, excellent thermal insulation. And here, I just did a little quick thing, like a red line exercise, so we've got water shedding, water resistive barrier, air barrier, vapor diffusion control layer, and the thermal barrier, all identified on this particular assembly detail. So we had a couple of details that were provided us courtesy of Cornerstone. Now, where do the weak points lie in an installation? This one happens to be an example of a well-designed install condition. There are no metal flashings. The metal sill comes just under the window, so there's no penetration into the thermal plane. There's a nice heavy upturn hidden underneath with an impermeable surface on top, so water is deflected and directed out. There are redundant seal layers to ensure continuity in the unlikely event of a catastrophic failure of one layer. And in my opinion, you'd be hard pressed to do better than this. I'd also like to note one other nice thing here. The subsill is flat on top. Now, a properly supported window should sit flat, not on a slope. Even the old sloped sill, like old double hung windows, the jamb legs ran past the sill and ended at 90 degrees. They sat flat on top of the subsill. This side jamb is also from Cornerstone Architecture. I want to take a closer look at this one to identify some of the typical concerns when detailing. So in the little blue rectangle I drew out there, you can see one of the most critical details in the building. This is the primary water seal between the window and the wall. In this case, it's a caulk detail to tie the frame into the WRB with an additional tape seal on top, belt and suspenders. On the interior side, in the blue rectangle again, you can see the continuous air barrier detail. It's worth noting because it's a tape seal that entirely covers the strap anchor on the interior face, which simplifies the process nicely. It's just one piece of tape covering the whole thing. It's pretty hard to make a mistake when doing something that's that simple. Now, I know this looks a little bit confusing. So what I've drawn here is to illustrate how an install detail might be more commonly done. So the red box in there is meant to be the jamb trim. So it's installed tight to the opening up against the window. The blue rectangle is the weakest point in the install, the empty cavity surrounding the window. Now, we try to insulate this, but it's a real pain in the ass, and it can be very difficult to ensure that the work on this is done properly on site. The blue line represents the cold exterior surface, and the magenta line is the distance the heat needs to travel to escape. It's pretty close. And in a multifamily building, this is likely to end up being your greatest thermal bridge to account for in the project. Now, this is the detail as drawn. It does a great job of mitigating the potential negative impacts on heat. With the thicker frame profile, you can get some insulation on there behind the jamb, multiplying the distance by several times. Similarly, on the interior, you have room to insulate again and wind up with a nice warm interior surface and likely no thermal bridging at all. A correctly detailed installation, well over insulated on a properly designed high-performing window, can achieve an excellent SI install, certainly thermal bridge free. That's not a problem at all. To forestall the question on it, I do not have the specific heat loss on this particular install. So this is the Diane in Portland, Oregon. This building did take pretty good advantage of Innotech's system capacity and capability, and designed windows that are very functional for the occupants. And I think it's a great looking building. Q21 in Portland. This one's kind of interesting. It's a really funky mix. They've got part of the building is turned like 15 degrees over the podium. It's got a mix. Some of the product is ours. Some of it is an aluminum curtain wall style system. It has these Juliet balconies. It has solar shades. We did a tour on there with a couple of architects that just wanted to view the project and the product for an upcoming project that they were considering. And when they asked the director of maintenance there, they said, "How are those mini splits working?" He said, "I have no idea. I don't think anybody's even turned them on. This building just functions so well. It's not an issue." 500 Northwest 23rd in Portland. This is a commercial industrial building, but they made great use of large openings. They tried to simplify as much as possible. You can see those Juliet balcony rails again. And the River West Apartments in Vancouver, Washington, on a similar vein. They have pretty good sized operators in here. Could they have simplified further? Probably. Did they need to? Obviously not. So this is pretty funky, and that's a gigantic building. If there was a place that would potentially suffer from a lot of heat gain from occupants, it would be this one. But they've got pretty substantial potential for ventilation throughout. These are a couple of different projects here. The Jeffrey in Portland. This one was actually I don't know what the term is that they use down there. It's like federally supported low-income housing. So they made use of the tilt-turn door. They wanted to maximize ventilation with the Juliet balconies, and the same Juliet balcony system was used in the Gastown project in Vancouver. And that is the end of the slideshow.
Fantastic. I think if everyone could unmute yourself and give Mike a round of applause here for a moment, I think it's in order. Well done. Yeah, it's awesome. Awesome. So now don't forget to mute yourself. So Mike, that was both this concise, comprehensive kind of primer on incorporating high performance windows into projects. Really well done. And you're getting great comments and questions in the chat. We have lots of questions for you. We also have some great comments, like Ali Zahurian says, I love the optimal window design. Nice idea. You've got some nice kudos about all the great visuals you were using. I'm going to also, I posted this once, but I'm going to include one more time the link to the video from your previous component spotlight that you referred to. So I think we're ready to jump into questions and answers. And we got a couple of questions from Mark Anderson. So maybe we can start with you, Mark, if you are still here. It looks like you are. So if you wouldn't mind unmuting yourself and asking. Thanks.
Hi, sorry, I wrote so many questions. I can't remember.
I've got them here.
Mike, excellent job. Fantastic visuals, fantastic presentation. You rolled through it. I'm very impressed. I guess first question is, I was confused by the fact that it says the metal is bonded to the UPVC, and I was corrected that it's actually fastened. Could you clarify that?
Sorry, on the Juliet?
No, on the UPVC, the UPVC frame has a metal reinforcement. Is that reinforcement bonded, which I assume is cemented, glued, permanently fixed, versus fastened, which is screwed?
So we have a couple of different product lines. So in our 76 TS series, which is steel reinforced, that was the one that was used in the Bagley Nature Center. That one is, the steel structure is screwed through the frame into the steel. But in our Passive House Certified product, it doesn't include any steel. So it actually has a PBT, which is a thermoplastic fiberglass reinforcement. It's a co-extruded heavy fiberglass reinforcement in there. So there's no steel or mechanical fastenings.
Okay, great, thanks. Secondly, another question was, it sounded like you said that the sashes are shipped separately versus installed in the frames. They
can be. That would be something where, if that was a strategy that worked best based on logistical considerations, the installation method on site, it might be just a factor of weight. For example, if you have some very, very large units, they can get very, very heavy. Right. So if you had something like that door side light unit, so you've nicely simplified everything, but it weighs like 400 pounds. So pop the door sash out. So the installers are only lugging around a 250-pound frame and glass and then a 150-pound door panel.
Great. Okay. Again, thank you. Great presentation. And if the slides were available, they were excellent, just to kind of keep it clear. Nice presentation. Thank you. I'm done.
Thank you, Mark. We'll have a video of the presentation available next week on the Passive House Accelerator site and on our YouTube channel as well. So next up for questions will be Harvey, John, and Hans. In some cases, folks may have answered some questions in chat. I'd encourage you to go ahead and ask your question of Mike anyway, but that's totally up to you. So next is Harvey.
Mike, great presentation. Thanks, Zach. Mine was answered by Thomas, but I'll just ask it again. Is there a longevity issue between the type of opening style? So you have tilt and turn versus casement versus, let's say, awning, or even like a double hung. I'm just curious if you guys have done any testing on it and which is the one that has longevity, because, you know, the main thing we always talk about, irrespective of the thermal bridges and continuous insulation and great windows, et cetera, is really durability. So that's where I was going with my question. Thanks.
Yeah, and it's actually it's an excellent question. Durability should be well considered when it comes to projects. I mean, the idea of, you know, I guess when I was a kid, they were apparently building houses for like 20, 25 years, which is like insane, because when I started in the industry, I was doing a lot of renovation stuff. I was restoring old counterweighted double hung sashes that were, you know, 100+ years old. Most of the time they didn't function just because that 75 layers of old lead paint on there sealed them shut. But in terms of long-term durability, tilt turn windows, I think, have a pretty significant advantage because the hardware basically wraps around the sash. It's balanced. So when you're operating the window, it doesn't have the same, it doesn't have stress on the hardware. It will apply stress to the frame, but the hardware itself isn't really being stressed in the same way as when you have things like a casement. If you've got that roto crank, then the weight is actually bearing on those scissoring pieces of hardware. And you've also got gear, like the teeth, the gears in that mechanism. So as you have heavy weights, as you have maybe wind loads, not just when it's open, but as you're opening and closing it, and so you have additional stresses being applied to the hardware, then you can wear out those gears much more quickly. And I know for sure that does occur, because I see a lot of specs that specify or that require these huge volumes of extra hardware. They want hardware components for maintenance purposes because they know it's going to wear out. They're like, oh, we're going to be replacing 10% of this hardware in the next 5 years. So you have to just include that. That doesn't happen with our tilt turn hardware. It's well built, well designed. We don't design or build anything outside of the hardware maximums. So it does last. And the way that it reduces some of those stresses, when it's moving, it's not jiggling and bouncing, and it's not falling out of square. So it does keep the actual window itself. It holds it a little more consistently. And so then you're going to see a little better longevity of the like the sash component. You're probably going to see better longevity on the sealed unit because it's not having stresses applied to it as well. So it definitely does have an effect. And I would say that you would probably see the durability go. Yeah, it's hard to say which one is better than another when it comes to stuff like awning casement. I would say single and double hung, definitely with the modern technology types rather than the counterweights. They will wear out faster or become problematic to use faster than a casement or awning. But casement and awning can depend heavily on the size of the sash. So the bigger the operator, the more stress it places on it, the faster it's going to wear out.
Thank you. That was a great answer. Fabulous answer. Thank you so much.
Okay, thank you, Harvey. Okay, so next up we have John Charmella. All right, going once, going twice. Let's see, John's question was, when not in the tilt position, does the window also open in a casement position?
Yes, it's so the tilt turn window, it's a dual action. So it will tilt for ventilation, but it also, it's an inward swinging casement operator.
Fantastic. Okay, next up is Hans.
Hey, Mike. Great presentation. I have a question about European versus Canadian or North American labeling of energy efficiency. There's always that discussion about, that they're actually just labeled differently. They may not perform differently, but what's your take on that?
Yeah, it's a great thing to look at, because of course we have the North American Fenestration Resource Council, anyway, the NFRC standard. So that establishes the energy use and the labeling and certification in North America. And of course, all of our windows conform to that. Whether or not it makes the most sense for your project could depend entirely on the climate zone. When they have that broader boundary condition, when they're going to -18, if you're in an area where -18 temperatures are fairly regular, then that might be a fairly appropriate thing to pay attention to. But for the most part, I mean, Passive House obviously has different climate zones, and it pays great attention to the differing conditions. And I personally feel that like NFRC is great for what it was intended to be used for, which is an apples to apples comparison between different window manufacturers. So at a specific size, which window or how does the heat loss compare between different windows? But in terms of how a window or door unit, what the specific heat loss is for the unit, and applying that to how it will affect a building model, the Passive House standard is light years ahead. Like, it is just drastically superior. But it all has to be taken in context, of course. If all you're going to pull is, oh, this person's got a label number here, this person's got a label number there, even if the European system, if they say it's passive, does that mean it's PHI? Is it I can't remember the name of the other, Rosenheim? You know, like there's more than one system to follow. So I definitely think it's worth paying attention to for everybody to look at what is being presented when the person tells you what the U value of their window is. Is that an NFRC number? Is it a Passive House international number? And is it a standard size? And then also beyond that, I think it's really important to remember that the North American testing and certifications that are required. It's not a joke. So when you have to have NFRC in an area, whether you're also reporting Passive House numbers, you still have to have the NFRC, and you're not going to get away with skipping the local testing. So if you're in a NAFS area, like everybody in Canada and several US states, you have to have that testing properly done. You can't just rely on one single standard window sample. So it's, there are definitely different systems. They each have their place, but they're not equivalencies.
Cool. That's a pretty complex topic.
It is.
Cool. Thanks a lot.
Thank you, Hans. Dale in Tacoma, did you have a question about the different approach to window installation in renovations versus new builds? Is that you wanted to share?
I can comment a bit. I've renovated down the street, and also my condominium in Whistler. Bought Cascadia finally after learning about windows. Bike produces great windows. I see we also have another Canadian manufacturer on this call too. Thomas Wimmer, I think you do windows, I believe, or did. But we have a difference in renovations because the window is square. The building may no longer be square, and how you measure is very critical. As my representative for Cascadia here said, he installs it, he measures it. And even then, because fortunately we have wood, they carved out some of the window frame when we got to it. And the ones in Whistler were pushed in because at that point I bought Mill Garden not knowing anything about windows. And the other So there is also things about putting the window in and what materials use around the window. We really haven't covered that well. Silicone, rock wool, foam. I use three things because I figure something's going to crack eventually. Silicone is what we use for the Cascadia, because now we're worried about every little millimeter and fractions of a millimeter around the window besides the window and the frame and not touching the frame of the house. And then there was the expandable foam that we saw demonstrated here with Solo once that many people did not seem to like, but some say they love it. So putting the window in is also very critical in how you put it in, how you measure it. And frankly, my tenant prefers opening the window versus the tilt. And if I did it again, I would have paid the extra money and bought 2 opening windows versus saving that $2,000, because I washed it outside once and was worried about, I didn't have a ladder and I thought it was a fall. So 2 open windows, spend the money, quality beats price every time. And then we had warranty issues. Milgard did cover my warranty. Harvey was saying his doesn't crank well. Even 12 years later, the computer found me and they sent the crank. So it's worthwhile saving your receipts because these things will last 20 years. The receipts are still valid, or whoever you bought it from might have gone out of business by that time. Hopefully the manufacturer hasn't. So there are a lot of things to know about windows, and when they get put in, you may have challenges later, but some manufacturers do offer warranty, and I'm glad Milgard did.
Great.
And I'm sure that these Innotech windows have great warranties for past our lifetime, probably.
Excellent. Thanks, Dale. Yeah, could you share information about the warranty, Mike?
It worked.
Yeah, we do have some. We do have a pretty good warranty, I think. So we have a little bit different warranty for like single family residential versus multifamily. So on residential projects, it's a 25-year warranty, 20 years on glass, 10 years on hardware and finishes. And for multifamily, it's pretty similar, but it's 20 on the frame rather than 25. And you know, those are some pretty good time periods to begin with, and at the end of the day, I think one of the aspects of warranty to pay attention to is also the company that's providing the warranty. Is the company actually going to be able to back that up or not? You know, do they have the longevity? Do they have the resources? Are they somebody who's going to be around when you want to call them up again? So I think that's a big part.
A key point. A key point. Great, and thank you, Dale. So next up we have Ali Zahurian.
Oh, hi, hey.
Yeah,
thank you too. Yeah, so Adrian already answered my question. Just ask about the shadow panel. So Adrian already advised us that the Innotech won't provide this kind of panels. Is supplied by others.
Right, the exterior shading is provided by another company. Is that correct, Mike?
Yes.
Yeah. Okay, great. So Hannah Monroe, you had a couple questions.
I did not, but maybe there's someone logged in as me.
That could be. Here are the questions that I say that I see that are attributed to you, Hannah, being asked on your behalf. There's is the active shading on the exterior and interior. Of course, that's exterior, but what is the material for the active shading?
I think that's Susan. I'll let her.
Okay, great. And then there's also a question. There's also a question about, could you elaborate on the semi-flexible strap anchor for structural connection? What do you mean by semi-flexible? So 2 questions.
Okay, so the first one is, so the material for that active shading solution, that particular one, it's called the Solix from MHZ, North America. So there's actually a whole bunch of different fabric choices that they have. So you can, I think you can go from up to about 80% rejection down to quite a bit lower rejection. So it can be more like a translucent fabric. But, you know, when you combine that, that 80% rejection with the solar heat gain rejection that the sealed units already have, you're probably down in the 4% solar heat gain range. So it's pretty effective. I went for the heaviest. I wanted it basically as like blackout, which it was, other than a little bit of light coming in the very edges. But when it's nighttime or early morning sun, nothing comes comes through, obviously. For those connectors, the strap anchors, when we say semi-flexible, what we mean is it's a pretty heavy weight. I'm not sure what gauge. It's like 14 or so gauge galvanized steel. So they're a heavy enough and rigid enough anchor that once you put them on and fasten them in, your window's not moving on its own. However, when pressure gets applied to it, you know, if you were to go and put all your weight onto the window frame, you know, before you've got everything all completed on the install, you can see the window move over a little bit. Like you can push against those anchors and press them in a little bit. And that ability to move. So, you know, we're not talking if the building shifts over a little tiny bit, if you get a little bit of wind movement pressing on the frame, those anchors aren't going to shift. But when the building is actually shifting out of plumb by a 1/4 inch, for example, and it would be pushing the frame out of square, the frame is going to resist that basically until the wall goes so far out of square that it's now pushing the window frame itself. And then, but I mean, that's a pretty big problem. You're having some major structural issues with your building if you see stuff like that start to occur. But the standard movement that you would expect to see in a properly designed building that has shear walls and everything like that, you know, you might see like an 1/8 inch of movement or something like that, and the window's not going to be affected by that wall movement.
All right, let's see. So next up is Benny Mcdonough.
Hi.
Hello.
Greetings
Howdy.
from Ireland.
Ooh,
Thanks for being here.
We used the windows today to get the temperature from our kitchen down to 20 degrees from 24 just by opening them. It's great.
nice.
Yeah. It's a quick question, really. I've just heard from a few people that the blinds on the external of the house or shading works better from keeping the heat gain coming in. Is that true, that it can stop like more than if you have the blinds on the inside, it can only like reduce up to 23% of the heat gain? So if you're designing, they should be in the glass or externally. Would you recommend that?
Well, it does depend on the building model as always. But one thing that's interesting, so Henry Nickel is on here. He's the MHZ North America guy. He's got tons of information, way more than I would ever want to know about window coverings, to be honest. But we were going over a couple of things the other day, and so he said the window shade that I have at my house, it's about a 3 to 4% solar heat gain when that is down in use. If I put the exact same fabric on the interior of the window, I would probably be closer to about 30% solar heat gain. So that's a pretty significant shift in the amount of heat that gets into the building. But one thing to, because I do have interior shading solutions, they're actually just like a simple, not a cellular shade, but a pleated shade. They have a reflective exterior surface, so they are going to reflect some of the heat back through, and there's a bounce back effect between the shade and the low-E coating on the glass. But some of the heat is going to make its way outside, and no matter what, it's blocking the direct line of heat. So it's being kind of trapped in the window opening, and it's making its way into the total building envelope. But if the building envelope isn't overheating in general, then everybody's able to stay comfortable. And it certainly seems to function for me. It's a pretty heavy Western exposure, and even in the heat dome last year, we saw on average about a 10 degrees Celsius temperature differential between inside and out. So when it was 35 outside, we were still 25 in.
Okay, thanks. Yeah, no, we're finding in Ireland now overheating is becoming a thing where it never was years ago. With the temp, with the climate and heating up and that kind of thing. So lots of people are looking into that kind of, to take into account. We had the hottest, I think in 2015, the hottest conservatory was 55 degrees. So obviously people weren't going in there.
Yeah.
Okay, thanks a million, Mark. It was a really great presentation. Very informative.
Thanks.
Thank you, Benny. Okay, so next up, Greg B. Let's see if Greg, yep, looks like Greg's here. Can you unmute yourself, Greg, and ask your question?
Yes, here's a question. How high you can go with PVC windows, especially with confined windows, I mean, European with reinforcement? Thanks.
Oh, well, there's a little bit of a dynamic in terms of like maximum height. There are differences to how large the window can be depending on color. So when it's a white window, obviously it has natural UV reflective properties and less propensity to retain heat. So building windows that are 12, 13 feet tall is not crazy. I think we can go taller than that. I'm actually not sure what the maximum extent of the manufacturing capacity that we have is, because one of the important considerations for everything is the actual the design of it. We have rigorous labeling programs. All of our products are commercially rated, so that's the L/175 deflection limitation is applied to it. So trying to maintain that extremely rigid plane is difficult at very high lengths. So we're able to maintain that commercial window rating and still build units that are 12, 13 feet tall. And then with color, we may limit it a little bit. And sometimes depending on elevation, maybe it's in the 11-foot range is the limit with dark colors. So pretty good size.
Sorry, just a question was, you're showing high-rise buildings with your windows. So looks like
you're talking about
possible, yes, leveling or
height limit for the product. We've had product installed over 30 stories high.
Okay.
So as I was saying, our products are all commercially rated. That's the big differentiation there. If you've got that CW rating, that limited deflection, if you've done all of the commercial testing, and pretty high numbers that we get for the PG ratings, or the DP, I think is the term in the US, the design pressure. So when you've got very high numbers with limited deflection, that's what allows you to go up into high rises, as long as there's not a specific code related to combustibility that would also limit it.
Fantastic. Thank you, Greg. So then next up is Kim Walton.
Hi there. Good morning. I love all this window talk. You guys, the last couple of days, it's great. So I had my original question I'm going to put second. I just want to talk a little bit more about the shades, window shades and windows themselves, just so that just be clear to everybody that if there's a shade on the window, It doesn't change the U value necessarily of the window. And sometimes when we're talking about heat temperature outside and overheating in the building, if you've got a lot of windows, you're going to have more overheating than you would if it was a wall. And I think that's got to be clear. A lot of my clients don't understand that piece as well. And so we do end up using a lot of exterior blinds to mitigate windows that are facing the wrong direction, but mitigate overheating. But that doesn't change the fact that cooling and active cooling is going to be necessary going forward as everything heats up on our planet. But my question is a pain in the butt question, and it's just about awning windows. So I really like awning windows in some situations, and I do like Innotech product, and I do like and many European windows, but nobody does awning windows, and I understand it's because it's an opening out situation and it's harder to seal. But there is a case to be made for using awning windows, especially at lower levels in a building, just looking for chimney venting and easy chimney venting. So is that even a consideration?
Well, for us, it isn't. We specialize in building dual action windows, and we always have. And there are some other manufacturers that build awning windows. It's a fairly commonly available product. Some guys may be able to create an awning window that strikes the right balance between the thermal values, air tightness, water tightness, ease of use, that sort of thing. But I guess that sort of falls back into that concept where not every product is the right fit for every project. So, or necessarily every location, maybe. We've definitely done a lot of multifamily projects in the past where, they may include like a design element of a curtain wall section. We don't provide that. Somebody else has to do that. So there's, more than one window manufacturer present on a project in some cases.
Thank you. Great presentation. Thank you.
Thanks.
Great. Thanks, Kim. Okay, next up is Tim Ian, who I think has a hard stop in 1 minute. So sorry, Tim, you don't have much time, but here you go.
It's a very simple question anyways. Thanks, Zach. Thanks, Mike, for the presentation. I'm just curious, if you were to compare, just your standard window, whatever, 3 feet by 5 feet, in sort of a multifamily setting or something similar, the Juliet balcony versus doing a mullion in the window with a fixed glazing unit below, I'm just curious, is one or the other generally cheaper? So if you had to pick, which one would you pick for economy? Just economy.
For pure economy, whatever is the most simple option is going to be less expensive. The Juliet balcony has a cost, both to build, install, maintain, everything like that. So if you don't add one, it's less expensive than adding one.
Okay. Yeah, that was literally all I had. And I wanted to second what the previous person said on the exterior shading and understanding the value and importance of exterior shading and cooling loads, especially here in North America. I've seen a lot of projects where that's maybe been neglected a little bit, and I want to encourage everybody here to look at that much harder and understand when to use exterior shading and what cooling loads are. And thankfully, the PHPP has gotten a lot better at predicting some of this stuff. So I'll leave you with that comment. And unfortunately, I got to run, but thanks.
Absolutely. Thanks.
Thanks for joining us, Tim. Fantastic. So I've got one more question here. So folks, if I missed your question, or if you have one that you want to pose, please put it in chat. We do need to wrap up soon here. We're pushing an hour and a half. We had over 120 people here. This has been an amazing information sharing session. So thank you, everyone. So the last question I have is from Michael Lind, and he does not have a mic, so I'm going to ask it on his behalf. He is wondering how your vinyl windows with dark bronze tolerate direct sun in Texas. And then also, what are your lead times, I assume, to Texas now?
Our lead times, to be perfectly honest, right now, they're not spectacular. We're in the 18 to 22 week range. We're just like I think everybody else out there in the industry, we're really busy. And so there's not much to be done about that. We've been working really hard this year to increase production. And as we increase production, it just allows us to take more orders. So just keep getting busier. But in terms of that, the bronze color, we kind of have one. It's called black brown, but it's interesting with our color codings here. So it just looks like black until you put in the sunlight, and then you can get that little tiny the hint of chocolate that comes out of it. But the backside of it is white. And so this particular coating, it's actually a UV reflective PMMA on the face, and it's a heat reflective white backing that's on it. So between the natural UV reflection of the surface itself, and then the heat reflecting properties of the specially designed white backing, then it means we can do the windows in very hot climates. As to the durability of the color itself, it would have the same 10-year color warranty. I don't know how much past the 10 years I would expect it to last. I just don't personally know. We could certainly look into that because I know the product has been used in very hot climates.
Excellent, great, thank you. Well, I think that does it. I don't see any more questions. There were quite a few. What a great conversation. So thank you, Mike, for this fantastic presentation, and also for the really dynamic Q&A that we had. Really appreciate it. And thank you also to Jessica Owens from Innotech for assisting with everything, making it happen, as well as Kim Davis from Passive House Accelerator. And a big thank you to everybody here in the audience who have joined us today for this really informative session with Innotech Windows and Doors. Also, thank you to Innotech Windows and Doors for its support of Passive House Accelerator. They help make everything happen here at the Accelerator, and so we're very grateful.